Principle of parallel axis theorem. So this is very important article in problem point of view, as well as to find out moment of inertia of any body if the position of the axis changes, which is the parallel to the known moment of inertia axis. Now let's see the statement. So the moment, let I tell you the mathematical statement here, and by mathematical statement we can write this one. This is a mathematical statement. Now what is IO, what is IC, and what is MH square? So that we can consider in a proof. So this is a diagram, you can see this diagram. Now in that diagram, this is O is the any point here. C is the center of mass. You can see in a diagram, C is the center of mass. Now if axis passing through this point O and body rotate about this, then moment of inertia of body about that axis is IO. So you can see in a formula this IO. IC is what? If we consider an axis which is passing through center of mass and body rotate about that axis, then moment of inertia of body about an axis passing through center of mass is IC. Then this mass is the total mass of the body. Then H, you can see here H in a diagram. H is distance between two parallel axes, or you can write a perpendicular distance between two parallel. ऐसे distance नहीं है, perpendicular distance है. So perpendicular distance between two parallel axes is H. So all the terms are known to you. IO means moment of inertia of body about any axis. O is the any point. C is moment of inertia of body about an axis passing through center of mass. M is the mass of the body. H is square of the distance, we can write H only, perpendicular distance between two parallel axes. Now this equation you have to write in word, then you will get the statement for parallel axis. Now how we write? So see here, moment of inertia of body about any axis is equal to, you can see here is equal to sign, is equal to, then this is sum of, so this addition sign, sum of moment of inertia of body about parallel axis. This axis IC is a parallel to this axis, parallel axis passing through center of mass. You can see here IC is passing through center of mass, and product, the multiplication of these two, and product of mass of body, M is the mass of body, and square of perpendicular distance between two axes, or perpendicular distance between two parallel axes also you can write. So only when you are remembering this statement, you have to remember this mathematical equation, and that equation you have to write in word, you will get the statement. Now proof, we have to prove this. So we consider a body, rigid body. Then we consider two axes which is passing through O and C. Then we consider one element or one particle in a particle of the body. Body made from n number of particle. One of the particle we consider which is present at point P. And the mass of that particle or mass of that element is dm. Dm is the mass. Then we join here O to P and C to P distance, as well as we draw perpendicular line PD on this line OC. We get this type of diagram. Now here we have to use moment of inertia formula. The moment of inertia of element, I am writing for element. About which axis? About axis passing through point O. Then moment of inertia formula we know, I is equal to summation mi/ri square. If I am talking about single particle, then mass into distance square is the moment of inertia. You can see here, this is the moment of inertia of this element at present at P, this whose mass is dm. Then mass is dm, and distance of this from axis which is passing through point O is OP, distance square. Dm into OP square. I written here OP square dm. Now this is for a single particle, moment of inertia of single particle about an axis passing through point O. When we are replacing this element word by body, then we have to take integration. So you can see here, moment of inertia of body. I replace this element word by body, and the axis is same. Then that moment of inertia we called it as a IO. So we can write IO is equal to integration of this OP square dm. So for single particle we are written, and then after that for body integrating by that. So this is equation number 1. Similarly, this is about axis passing through O we are written. Similarly, we can consider everything for this axis also, which is passing through this point C or center of mass. So moment of inertia of element about an axis passing through point C is, when we are talking about point C, then mass is again dm and distance is c to p, so cp square. So you can see here distance square into mass. This is the moment of inertia. Now I'm replacing this element word by body, then we have to integrate this. So I'm replacing element word by body, then moment of inertia about that axis we represent by IC. You can see here in a diagram also we shown it IC. So it is equal to integration of cp square dm, equation number 2. We get equation 1, we get equation 2. Now we have to prove this by using this. You can see here IO is written. Now you can see IO is this left hand side of the equation 1, and this whatever we want to prove it is same. It means that in equation 1 we have to substitute OP square by using diagram. So OP square we can use Pythagoras, then here by Pythagoras we can substitute OP square and we simplify it. That is the next step. So you can see here. So from this triangle OPD, so from triangle OPD, OP square is how much? You can see this OP square. OP square is this OD square plus this PD square. You can see a diagram. So this OD square plus PD square. But this OD we can write, it is addition of OC plus CD. You can see this diagram, OC plus CD, and this PD square as it is. Now after that, this bracket we can expand by using A plus B bracket square expansion. Then we get, so this OC square plus 2OC CD into the CD square. So let us write it down next step. You can see OC square, 2OC CD plus CD square, and this PD square we are written as it is here. But here these two terms, CD square plus PD square, again by using Pythagoras, and we have to use this triangle CPD. So this CD square plus PD square is CP square. So instead of this term, we can write CP square, and we can write the next step. You can see the next step here. So this OP square as it is, this term as it is, this OC as it is, 2OC CD as it is, only instead of this term I written CP square here, you can see. Now after that, we have to substitute this equation of OP square in equation number 1. So OP square we have to substitute in equation 1. Now equation 1 is integration OP square dm. Now this is OP square, we substitute. So we get this equation. Now in that, after that we have to simplify this equation. This integration we have to apply to this every term of this bracket, as well as dm we have to apply to every term. We have to multiply dm to every term of the bracket. So you can see the next step here. So integration, this OC square, this shape I written as it is. Then we simplify the bracket. So this integration OC square dm. Then integration 2OC CD into this dm. Integration CP square dm. Now after that, this OC square, you can see this diagram. This OC is stand for H. So I written H square. But it is a constant, so I written outside the integration. So H square, then integration of dm. Then this OC is H, so 2H we are taken outside. Then this integration CD dm. Then integration CP square dm as it is. Now after that, you know that this integration dm is the mass of single element. And if we add all the element, we get the total mass. So integration of dm is the total mass m. Then this 2H integration CD dm, it is coming 0 by definition of center of mass. So you know that all the mass of the body is concentrated at point C. So this D point does not exist here. So this CD does not exist, means it is 0. So here basically this is 2H integration CD dm, it is coming 0 by the definition of center of mass. Now let me substitute. After the substitution, we are written IO as it is here. This H square as it is, integration dm I written m. This term is 0, and this is equation number 2. So this is by equation 2, it is IC. So that we are written here. Then after that, we rearrange the term and we write the final expression here. So IO is equal to IC plus MH square. And this is expression for principle of parallel axis theorem, and which we proved here. So this question is asked many times in board exam. You state and prove this principle of parallel axis theorem. So you have to remember this very well.